Hi everybody, it's Mr. Spudik again. Today we're going to talk about range equations. There are actually three equations. Okay, I call them the range equations, but the range equation will be one of three. I also call it the plug and chug equations because as opposed to the projectile motion problems you've done already, now we're not going to worry about just components. We're just going to be given a velocity. Okay, it was fired with this velocity at this angle. How far away did it land? All right, so let's talk about the range equation. I'm going to apologize for the handwritten parts. For some reason, the equal sign and the theta didn't go through on this iPad. Okay, now range. What is range? Range is the horizontal distance that an object will travel when it goes through the air. Okay, so if you think about it has to be at an angle, okay, and it has to be a symmetrical path. So the range will be something will be used when something goes up and comes back down and you have a nice symmetrical path. You cannot do this with something that's not symmetrical. Okay, so you have an object that's going to be fired. The range is the horizontal distance from where it was fired to where it hits the ground again. Okay, so the equation is this: range is equal to the initial velocity, not a component, not vertical, not horizontal, but the actual velocity. We're going to square that velocity, all right? Then we're going to take the angle it was fired at, double it first, and take the sine of that. Okay, so if you want to think about the parentheses there are parentheses, but you will take the angle, double it, and then take the sine of that, and you're going to divide it by the absolute value of gravity, or 9.8. Okay, so range is used in a lot of things. Now, obviously, you could use range with watching sports, watching a baseball go across, and see how far it travels. In the military, there are things called mortars. Okay, so if you're interested in the military, or if you play a lot of military video games, you might know what a mortar is. And I'm not an expert with this, but the idea would be a mortar is something that's going to get fired, and it has a set velocity. And if you change the angle, all right, it changes the range. You can't change the velocity with a mortar, but you can set the angle to get it to go the distance you want to travel. Okay? All right, let's give it a shot. Let's try this equation here. So we have, let's say as an example, I have an initial velocity of 112, okay, an angle of 35 degrees. What would the range be for something that's fired at 112 meters per second and at an angle of 35 degrees? I'll pause it here and let you try. Okay, what did you get? Well, let's see. If I do this, I'm going to have my range equation is v squared sine of 2 times the angle divided by 9.8, okay, or g, absolute value, okay? Again, remember, it's not sine of 20. Sometimes students, that's a common mistake. They see sine of 2 and they're like, I don't know what that other symbol is. Must be a 0. That's not sine of 20. That's sine of 2 times the angle. So if I want to make it look the way it would look in a calculator, I would say 112 squared sine, and a parentheses would open up, 2 times 35, close my parentheses, don't forget to do that, divided by 9.8. Okay, plug it in. Make sure your calculator is set to degree mode. Okay, you need to make sure. And if you just came from math class, your calculator might be in radians. So you need to go and figure out how to change your calculator from degree mode or from radians to degree mode. All right, but we should get an answer of 1,209 meters. How do we do? We do okay? Okay. If you got a wrong answer, I think the first thing you need to check is the mode and make sure you're in your degree mode. If you do check that and it's still wrong, maybe parentheses, okay? But try it until you get that right answer. All right. Now, if I want to get something to go the farthest distance, what angle do you think that would be? Okay, don't look at the paper. Or don't look at the notes right here. Oh, you already looked. Okay. Yes, 45 degrees. So the way you can think of it is this. If I fired something straight up in the air, okay, at 90 degrees, it would be in the air for a really long time, which is great. However, it would have no horizontal velocity to it and it would come straight back down. So the range would be 0. Okay? If I fired it at 0 degrees, I'd have a really, really high horizontal velocity and it would immediately hit the ground. It would be in the air for a time of 0 seconds. So if you need to find that happy medium, it's going to be 45 degrees. Okay? So we will say sometimes that something's fired at maximum range. And that's just us physics teachers making sure you know that if you wanted to go the farthest distance, it has to be 45 degrees. So if anyone ever asks, or say it's on a test, what is the maximum range of this projectile? The answer is not 45. The answer will be what you get when you use 45 in the range equation. Okay? All right. Next equation, time. This is the total time in the air. So again, think about that picture, that nice symmetrical picture. So the total time in the air will be equal to 2 times the initial velocity, whatever it's fired at, times sine of the angle, so whatever angle it's fired at there, divided by gravity. Again, absolute value of gravity. So let's try that. Same numbers. All right? So I have an initial velocity of 112. I have an angle of 35 degrees again. What will be that time? I'll give you a minute to calculate. Pause me here and figure it out. Okay, how do we do? Did you get an answer of 13.1 seconds? All right. The way it should look in your calculator, again, would be time. So the equation is time is equal to 2vi times sine theta over g, absolute value. All right. In my calculator, I should have 2 times 112 times sine of 35, close your parentheses, divided by 9.8. And you should get that answer. All right, again, check your mode. Make sure you have it in degree mode. All right, the final one is the ugliest one, height equation. And this is talking about the peak height. So if something's traveling, all right, at the halfway point, we want to know what's the highest point, which will be the halfway point, okay, because this is a nice symmetrical path, all right? But what is the peak height it will reach? So we have, again, initial velocity. We have sine squared theta. Now, this is a mathematical way of showing it, okay? In your higher level math classes, this is the way it would look. But what it means is you take sine of the angle first and then square it, okay? So you would take sine of your angle and then square it. When we practice it, I'll show you what I mean. Okay, and then it's divided by 2g. So not just 9.8, but basically 19.6. Okay, let's try this one. Again, initial velocity of 112. Angle of 35 degrees. What's the height? Pause it here and see what you get. All right, how do we do? Did we get 211 meters? Maybe, maybe not. Well, let's do it. So again, our equation is going to be for height, initial velocity squared, sine squared theta, divided by 2g, absolute value. Okay? So the way it should look in the calculator is I do my 112 squared. I would do sine of my angle, 35 degrees. Now, in a normal TI calculator, you would have parentheses already showing up. All right? And then you square this value. I'm going to exaggerate and show another set of parentheses, just so you understand we are squaring the whole thing. Now, in a TI, you wouldn't need those extra set of parentheses. The TI knows take sine of the angle first and then square it. Okay? But just to overemphasize what it would be like. Okay? And then divided by 2, and then divided by 9.8. Now, this is the way I would do it to make sure both the 2 and the 9.8 are down below. What some students might make a mistake of doing, and again, this is another common mistake that students will do, is sometimes they would have divided by 2 times 9.8, and they get a wrong answer, because the calculator would think that the 9.8 is up top with the other values. Okay? You could also do parentheses. So if you really have to do it that way, then you really need to have parentheses holding together the 2 and the 9.8. But I think it's easier to say anything on bottom I'm going to divide, and I'd say divided by 2 divided by 9.8, and I should get the right answer. Thanks so much for watching. I'll see you later.